Okay, thanks a lot, Marco. And welcome on my behalf to, as Marco already introduced me, my name is Petteri Pyykko, and I'm a forecasting meteorologist at the Finnish Meteorological Institute, and I'm going to give this weather briefing about mainly about Europe's current weather situation, and afterwards talk briefly about yesterday's convective situation we had in Finland. And let's start at first. Could you please tell me where you're participating from with the marker? And also, if you're a researcher, manager, trainer, or if you have some other interest why you are participating to this weather briefing. Okay, looks like we still have people from many parts of Europe, although it's already June, and I know that some of you might already have vacations or a lot of some of the EUMeTrain people at least. Seems like we have a lot of forecasters here today, and yeah, thank you. Let's move on to the presentation. Here first. I have a water vapor image from this morning. It's from 5 UTC. It was a bit tricky, I would say, because with the first look, you would say that, or you could say that the jet stream here is like totally connected and flows to the same direction, but that is not actually the case. As you can see, the slides after this one, but there is clearly jet stream flowing here where the upper level circulation is present, and these upper level lows and circulations can be spotted where the color is darker because that indicates sinking air or drier air. And here over the south eastern part, we also have this circulation. It's not very clearly visible here, but soon you will also be able to spot that as also here over Iceland, an upper level low. And actually, I think this part is due to a saddle point, but I'm not completely sure about that. Here, the jet is actually moving to northeastern direction. But I overlay the geopotential, so it's a bit easier to see. And this upper level trough here is actually very large. It's almost you could almost say a cutoff low, a big cutoff low from the main circulation. And but I'm not sure if it's going to strengthen too much further, because there might be some, or there is some with ice tags easier to explain. Some negative vorticity advection from the base of the trough present there. And also some positive vorticity advection to the north of the base, but still, according to the weather models too, it might not strengthen a lot further. It might actually start weakening soon. But here from this image, the upper level low clearly visible over Iceland, and an upper level short wave trough to the west of Norway, and then this large area of lower heights over southeastern parts of the Europe, and then we have this huge big upper level ridge, which is very strong and causing the extreme heat that we are currently experiencing in many parts of Eastern Europe. Here is once more with the ice attacks, and the strongest jet can be found here over Sweden and Norway, flowing from southwest to northeast. And still, as can be seen, there is a lot of available moisture in many parts of Central Europe, Southern Europe, Southeastern Europe, and also over Finland. The air mass currently over Finland is very warm and very moist. I think that actually, if you look very carefully, the whole Finland is actually a bit more brighter than, for example, the Baltic countries and Poland and many other countries because of the high moisture content. Next, I have the air mass image, and very warm air mass can be found in south and southwestern, south and southeastern Europe, and it's indicated with greenish color. The greener, the more moist the air mass is. But here over Eastern Europe, the air mass is also very warm, but locally, or in many parts actually, it is also very dry, so that's what causes the reddish color. And in some parts, for example, here there is another branch of the jet that is over the air mass that is due to descending. The orange color is mainly due to the descending air, which is also visible here on the southwestern parts of Europe, where you can see the jet before in the models and in the water vapor images. And also here over Iceland, some orange due to descending air, very vaguely visible to the west of Norway with the jet. These pictures are always worse the more north you go, with lower viewing angles, as is a very well-known problem in western Russia with the ozone absorption effect that causes deceiving blue color at the very low viewing angles. And one more thing about this image, it is quite hard to see because there is quite a lot going on here, but you could probably also see that there is some colder air mass associated with the low pressure activity, and here mainly over the northeastern parts of Atlantic. Next, I have the model output from 00 run of ECMWF's weather model. And as we can see from here too very well, large areas of Eastern Europe, Southern Europe, Southeastern and Northeastern Europe are under the influence of this. Eastern is under the influence of this ridge, and then there is another ridge in Southern Europe that is transporting very warm air from the Sahara from south to north, which is also helped by the upper level low over France and Spain and southern parts of Germany. And as we can see, the air mass temperatures are actually quite subdued over parts of Portugal, Spain, France, UK, definitely Iceland, and north eastern parts of the Atlantic and Norwegian Sea, and here lately over the northeastern parts of Atlantic and Norwegian Sea, the low pressure activity has been, well, quite active, and that has also helped partially bring the colder air masses from the Arctic, and partially because it doesn't have any time to warm up. And the next, I have this convective storms or severe storms, how you want to call it, RGB, from this morning. On the left, and on the right I have approximately from the same time I have the observed lightning strikes in Europe. And as we can see, this is quite useful for observing convection, because especially on these days where there in many parts there isn't a lot of higher, colder and thinner cloudiness, or sometimes, well, of course, it can be thicker to higher up in the atmosphere. You can only monitor and pay attention to the developing convective clouds, and have the lightning detectors, the map ready for comparison. And the highest tops, the coldest tops, are depicted with this yellow color. Also the thick high ice clouds with very cold tops. Oh, sorry, with the very cold tops, or the smaller ice crystals are shown in the same color as the very high convective clouds. But as I said before, now there is not a lot of those visible, at least in the morning, and then you monitor the convection later on in the day. A very useful product. And here the red spots are where the particle size is a bigger at the top, and also the tops are not as cold as with the yellowish, or in the yellowish areas. And one more note, and as we can see, these yellowish areas here, the coldest tops, correspond very nicely with observed lightning strikes already early in the morning. The activity kicked off in many parts of Europe. And I still have a few satellite pictures left from Europe. There is a day natural color image. It can be used with combination of other satellite products, and very useful for displaying surface characteristics such as snow, vegetation, bare soil. Here, and the high ice clouds appear in cyan. Here over Poland, over Turkey, over Sweden, over France, and then the higher frontal cloudiness over the Atlantic. And this is also very useful for distinguishing between the water and ice phases, because the water clouds are not depicted in cyan. Instead, they are depicted in gray or white. For example, here, lower cloudiness over Spain, over the Atlantic, west of Portugal, and south Sweden. then made this quick analysis of the cloud types using the day-night microphysical RGB from this morning, and I put these numbers where I think the positions of these clouds are. And here first, the low to middle level clouds with larger particles. I tried to compare as I reached the time with the observations, at least here over Spain. There was some drizzle and also some fog combined, but I'm not very sure if people use this for denser fog, because like it can easily be confused with or mixed up with drizzle in some cases. Here in over the same in over Sweden, over the Black Sea. Then we have the number 2, thick ice clouds with small crystals on top. They can be found in quite many places where there was convection today. At the same spots as before with the severe storm RGB over Sweden, Poland, Turkey. And here the front, this is mainly the frontal cloudiness that just pushes higher up in the atmosphere. And then I wasn't completely sure of this fourth one, but I think it's just from Sahara, because I know that during the last days and weeks there have been large quantities advected from the northern Sahara. But please correct me if I'm wrong with this one. And this might not be the best product for that anyway, because if there is some semi-transparent ice clouds, there might appear with the same or in the same color as this dust. And then last, thick ice clouds with large ice particles, not visible in too many places in this morning image, but I think I found some in the northern Scandinavia over northern Norway and Sweden. And then I took I think these were pretty much the latest warnings. I just snapped the picture before the briefing started from Meteor Alarm, the weather warnings in Europe. I apologize for a few white spots. I don't know why they are lacking. But as can be guessed, many heat warnings over Eastern Europe, also over Southeastern Europe and Scandinavia. Even some red warning for heat in South Italy, associated with another ridge, as we could see before, and the very hot air mass advected from Sahara. Alongside with this, in many parts, rain warnings, severe thunderstorm warnings, and I could spot also wind warning in the Netherlands. I think that is on the coast, but it's mainly this summer phenomena due to very high energy content and moisture content in the atmosphere. And now I finish with this a few slides about the convective situation we had over northern Finland yesterday. I chose these 2 pictures or 2 images here. On the left side, you can see this colorized IR clouds from NOAA 20 satellite using the VIRS instrument, and on the right side, from the same time stamp, the one with natural colors with IR clouds, and here on the right, the color coding is the same as with the product from before. The this one, the day natural colors RGB. But as you can see, very active, locally severe thunderstorms over northern Finland. Um, I'm sorry, I forgot the name of this area in English. In Finnish, it's Pohjois-Pohjanmaa. I'm not completely sure if it's called Northern Bosnia in English. And then here is Kainuu, where the storms further moved later on. And this is a mesoscale convective system, and then on the left, to the west of it, there are some supercells and just single cells too. And the ingredients for this event: air mass temperature very high for whole southern and middle and northern or southern parts of northern Finland, but especially this area of interest, air mass 14 to 16 degrees high, and the deep layer shear 20 meters per second, locally even higher. The surface 0 to 1 kilometer shear up to 15 meters per second, supportive of supercells that could give large hail and even some isolated tornadoes, very high Cape values, very high mixing ratios. And the synoptic situation was that we had this frontal boundary here with the colder air up north, and so very warm and moist air pushing from the south, and this thunderstorm just developed yesterday and also today in pretty much the same places. And the total lightning strikes detected yesterday was almost 17,000 over Finland, and almost 40,000 in total. And some impacts. I'm sorry, I didn't have time to add photos from the internet. It would have been quite interesting to see some of the videos and images, but I only could reach the time to put this from this tilannehuone, which is a situation room, roughly translated into English, and where you can see where they put the labels of fallen trees and other kinds of emergencies on the cases on the map. And one very strong supercell unfortunately hit the city of Oulu yesterday, and it came quite fast. Some of the people didn't have too much time to, or many people didn't have too much time to react. It produced very strong gusts and a sudden, quite fast burst of torrential rain that led to some flash flooding. The max gusts in Oulu Vihreäsaari Harbor, 31.3 meters per second. Oulu Airport, 23.6. And yeah, as I said, caused many fallen trees and even ripped off structures such as ceiling panels from some of the buildings also in the center. And unfortunately, one person lost his or her life due to a fallen tree. And further up north in Rovaniemi, that is about 200 or 150 kilometers to the north east of Oulu. Rovaniemi Airport measured 65.1 millimeters of rain during yesterday. And it was, I think, if I remember correctly, during 1 hour, it was 26 millimeters, the highest reading. And also yesterday at one point towards the evening, maximum of 11,000 households were without electricity. Then, oh yeah, sorry, I forgot I still had this. And here is the 2 meter temperature and pressure deviations from EC. The first is this week. The next slide is the next week. But as we can see, the ridge is causing highly anomalous temperatures over Western Russia and yeah, for Santa Claus in Rovaniemi. It's causing very high anomalous temperatures in Western Russia, in many parts of Finland, the Baltics, over Eastern Europe, which can also, and of course, the pressure anomaly can be seen on this pressure anomaly deviation map too. Slightly lower pressures over southern and mid Europe, and then the subdued temperatures over Western Europe. But that is about to change, and here is my last slide. The next week's pictures. The ridge is moving to the south, and it's going to weaken a little bit. More seasonal temperatures are on the way to many parts of Scandinavia, even Central Europe, some parts of Eastern South Eastern Europe, but still due to the advection of this very warm air mass, some parts of southern and southeastern Europe may stay warm long till the end of next week too, and it's also going to warm a little bit over Western Europe. But the low pressure activity still shows some signs, or doesn't show signs of letting go over Iceland and the northeastern parts of the Atlantic. Yeah, now I finally finish with the highest measured temperatures in Finland. Today, I'm sorry, it is not very well visible. I very quickly put it, but at that point, the highest temperature was actually measured in my hometown in Pirkkala. It's near Tampere. Here it's 33 degrees measured almost at 3 o'clock today, the afternoon. 33 degrees, very high reading for June. And as you can see, in many parts of South and Mid Finland, 30 degrees or above. With that, I finish. Kiitos and thank you. And now it's time for some questions.